should at least put a date. We're in 521. So, what else do we know about what Ernie's doing? I heard some judgment being passed about his yard. Colin?
He's adding 3-foot wide decks on 2 adjacent sides of the thing.
Is that given to us?
Yeah. In part A.
Okay, so sorry, I was thinking about the wrong part being given. What don't we know? The size of the hot tub.
That's what we're looking for. Maximum size you can get.
All right, so 3.
Yep.
Okay. In my brain. Well. Oh, so you're saying here would be 9?
That's 9 square feet.
So that, and the whole thing can be 169. Okay, so we know, so the deck, we were told, is 169 square feet.
So it has to be,
If it's a square, then its width will be its length. So we know x squared will equal 169, and we're able to solve and get 13. So the hot tub is going to be 10 feet by 10 feet, which is not a small hot tub.
Yeah.
It's pretty big. You could lay it completely down. Maybe he likes his hot tubs.
Yeah.
So, help Gabby then. Gabby's creating a rock garden. Help Gabby out. If that was too easy, help Gabby.
How much is it back there?
All right.
So that means the inside is going to be in 11 by 11. Yeah, it's 12 by 12. And then you subtract 1 foot because of the 6 inches on both sides, so that gives you 11.
We are correct. And because we're such a small class, totally talking loud enough, that we can figure out that the 6 inches, or if we want to convert and have a common unit, we can say that these edge sections are going to be half a foot each. Which means if we have a half foot and a half foot, and this span across the middle has to be 11 feet. So imagine, and this is what we do in landscaping, a 6 by 6 beam that you're going to run down the length here, down this edge, this 6 inch by 6 inch beam is going to contain your rock garden. So if this width here is 6 inches, and this width here is 6 inches, then what Ethan was saying, is if we have 6 inches on both sides, the rock section itself is going to be 11 feet wide.
So she needs to cover 121 feet.
Oh, okay, I think I get it.
Wait, but the whole thing itself is, the entire thing in the wood frame is 12 square feet.
Yeah, but the only part you're covering rocks is the 11 by 11.
So
How about 12 is not 12 and 11?
12,
it's not a 12 by 12.
Yeah.
We're not talking lengths, we're talking area. What we know is the area. So, and if this is squared, then all right, we know x, or something like that, squared, is 12. So be careful when you're arguing and you're making quick decisions. Length, area, be very careful. 12 is not a perfect square. Now, what we've been told, we can use what you were talking about because we do know 1 foot, right? 1 foot is going to be taken up here and there, and 1 foot is going to be taken up here and here. So we could say that actually, if we call this like z across here, we could say that z plus 1 is the width of the garden, width or length.
Do we get it
on that?
wrong, or do we get it?
That squared would equal 12.
I'm confused right now.
So, what Ethan was saying was if we know 6 inches on both sides, that adds up to a foot. So the span across here is some distance plus a foot. Because the 6 inches given to us is how wide the wood frame is. Imagine like a 6-inch beam that's going to enclose your rock room. We don't know what this is across the middle because the only other thing given to us is feet squared, the area. So we're going to set up the area of the square is 12, but we only know that the length is something plus a foot if we want this to be given to us in feet. And because this is feet squared, we need to be working in feet over here. So how do we deal with this? Play with that for a minute. Try to figure out how we can solve for that z. It's not 11 feet. That'd be a huge rock garden. That's all. Rocks are expensive too. It's like seriously.
Yeah, it'd be bigger than the hot tub.
Man, you put in a hot tub and a rock garden?
I'm gonna do that. Oh my gosh.
So wait, if we just take the square root of 12. So if we take the square root of 12, then z plus 1 equals 3.461 subtract 1.
So I think most of us are reasoning through. We want to take the radical of both sides. We then will get z plus 1 equals approximately 3.46. But not that this matters in this situation. Remember when we work with square roots, our answer to a square root is always what? When what's the square root of 9? And? So, if we weren't speaking literally about a real situation that physically exists, we'd have to talk about plus or minus. Now, even when we're talking about real situations that exist, give me your eyes for a second. You were all like, oh, forget this because we're talking about lengths. Because we have something else to do, we're not certain yet which answer we're going to use. We got to think about both. Even though we're going to trash one at the end if it's negative, we got to remember that it's positive or negative. Because the last step here is to do what? Subtract 1. So z will equal, well, from the positive, we'd have 2.46 or negative 4.46. Has to be this one, but in certain situations.
But what's the area? So the actual answer is 6.0747967.
Yeah, how much area? So we will take this z Question? So we got to keep rolling. Look at 60. Now, it's obviously asking us what properties do we use. We kind of reason through these all together. But then you can catch on to what they're trying to get you to see with A, B, C, and D. So check those out, work as a group. I'll give you a few minutes.
Is it telling us to find a at the bottom what method we use? Is it telling us to write down what method we use specifically?
Yeah, just to show your work. Like, how do you arrive at X? So it's kind of asking us, did we use like zero product property, or did that sort of like
Specific definition of zero product property.
that if we have one item or two items, any amount of things that together produce or multiply to make zero, one or multiple of the pieces has to be zero. So when we have the answer of zero, well, we reason through those two options for how to get there. Installing I mean, we have one at the front door. They took our keys away. Well, they took the locks away. There is no like key lock on most of these doors. You just you have to have the electronic scanner. Safer.
It's safer. There's a little.
This.
Sort
Um. Hey. You don't tell me why I drew that bracket or what train of thought you took to solve it. Huh?
PEMDAS. You have to
Okay.
work with the, inside the parentheses first. So, yeah.
I worked backwards.
So we can't work inside the parentheses.
So you work backwards.
Yeah, so we have to work backwards, right? Because if we're trying to get x and we can't do anything with it, gotta work it backwards.
So first I have to do square root of 4 and to the other side.
And do taking the square root is one really good way, and that's the way we're normally going to take. There's another thought process that a lot of people will just kind of look at this and say, oh.
Well, yeah.
Couldn't you just make the 4 be the side?
We could. Let's not do that quite yet.
Well, I didn't technically do that. I just looked at it and was like, what squared equals 4?
Yeah. So the other thing we can think is, okay, what squared equals 4? Okay, most people are going to say 2. How do I make this 2? Well, what minus 1? 3. So the problem is when we look at the negative, we can't just say 3 or negative 3. So that's why we work this process backwards. And we would want to show that x plus 1 equals radical 4, which is plus or minus 2, positive or negative. Sorry, I should not say plus or minus. Then we get the, this is minus. It's minus 1. So that's how we get 3 or negative 1. past that yet. So for B, this should look familiar. A zero product property with a perfect square, right? So really just what makes this 0? 1. And C.
It has imaginary possible. You can't square something and have it equal negative number.
Multiply both sides by -1.
Oh shoot. What are we gonna
So
do about
then
complex numbers?
negative
Equals 4.
the opposite of something squared equals 4.
Huh? Still not
That
possible.
doesn't work.
So I like your thought process, but listen, the opposite of something squared equals 4. Something squared will always be positive. So you're right, and so are you, and so are a couple people, although I don't think anybody called it the right thing. Imaginary numbers is technically, well, it's what we often say, it's not complex. We're not going there yet, but what most people call imaginary numbers.
We learned that. No, we were talking about imaginary numbers once.
That imaginary numbers are real,
No, we
that
just
they
know
exist.
some-
The imaginary is a name that was made up. This is the problem. I like your face because I've made the same face too.
Numbers squared equals
Imaginary doesn't. So imaginary is not like your imaginary friend. Like, okay, we'll let you believe it exists, but it truly, like, there's nobody here. They actually exist. Imaginary numbers actually exist. They don't work in the math that we use. So they exist in a plane. If you take the real number plane and you had it here, these imaginary numbers are lateral to the plane. They are on a different. We'll get there. We're not going into it today.
Doesn't sound right.
It's weird to explain. It's kind of imagine that we're doing a 3D way, kind of.
Yes, it's like dimensions of numbers.
It's not any number.
That's gonna be
I can
fun.
write them out like
It doesn't fit under the
It's like trying to imagine
it's
color.
like
It sounds fun.
So
it is fun.
here, because it doesn't work, our answer is the empty set,
No solution.
no solution. For now.
Oh no.
For now. We're not going down that road.
When are we going on that next year?
I'm still trying to figure out how to navigate CPM. I'll see where we fit it in. I don't want to hit you with it now because it'll just like freak you out. And right now you don't want to have to do this.
How do you know, Owen?
I mean, it's things you can look up.
Why would you just look up are imaginary numbers real?
Because I've talked about it before. Yeah, I know.
Dave, I don't know if you were there when we talked about it during the summer course too.
No, I know, I remember. But...
Oh, the summer course. That was.
Wait, you did talk about it during the summer course.
We did.
We had a lot of
Yeah.
good conversations, and we're having a weird one now. So.
Yeah, we had muffins too. Yeah. Alright, I'm done.
The muffins are good.
Okay.
Okay. So, let's look at this. We've worked with these types of models with advertise. But when we solve this, what do we get?
Call that
Mm-hmm.
a weird number.
Square root of 12. Oh, no, my battery's low.
It's like points. Yeah, point
No,
four.
exactly.
3.46410165.
We have to write it in radical form.
Ah,
Because that's exact. And
So-
exact form is just estimate.
that big old decimal, as we see here, is irrational. Does not work because it's not a perfect square. Now we could factor it into its perfect square pieces and non-perfect square parts. Or, to start out with, we can just write radical 12 and say we have a positive and a negative option. We know that whatever that value is, that 3.464101, that has a positive and negative, but we're not going to write the big old decimal, we're going to write the radical. That's equal. I keep having plus instead of minus. So then x can equal the positive or negative of radical 12 plus 3. Now, how do we... Yeah. Anyone know how to factor radical 12 a little bit further? Okay.
Well, see, radical 12, you want to look for like perfect square factors. So radical 12 has like 4 and 3, and 4 is a perfect square. So when you take the 4, you know that it's when you square it, well, when you take the square root of it, it's 2. So basically, the 2's on the outside of the radical, and the 3 is still inside. So
we end up with positive or negative 2 times radical 3. If we wanted to factor that further. You don't have to quite yet. But that's how we do it. We break it up into perfect square, non-perfect. We know that the product of square roots is just like the product of the square roots. We break it up. Kind of break it up. All right. You can read all this, but essentially work to solve these problems.
Wait, how are you going to teach somewhere math to 1 with CPM?
I have already said that. I'm getting burned out. I can't keep doing summer school for so long.
You're doing
I need a
something
break. I will probably stay on as like an advisory type role or co-teacher or something.
Yeah, no, you'd be stressing people out. You'd be like, the session is every time.
You would be like stressed out. Like,
No, she'd be like,
Okay. We got 6 quadratics here. We got to see if we can solve and how.
what if what if it's the same thing?
wait a second. What?
Alright, really quickly. I'm going to take 15 seconds to show you what we're talking about. So here's a parabola. Kind of like what you're going to look at with number B. When does this parabola equal a negative value? Well, okay, right? If we have a parabola, it could cross over the -2, but what if it doesn't? What if it's all positive? So it could equal, that's +4 right there, it could equal +4 in 2 different locations. But never is this red parabola going to equal -2 how we see it. So we look at the other plane and yeah, he's like unfocusing. So he flips it, lays this plane flat, stretches the parabola up. We'll talk more about this one day. We'll watch the whole thing.
Whoa.
I have seen this video.
Is that real? Wait, no, that's fake.
No, it's no, we're not
So,
gonna do that.
this-
Lift the thing up.
This is the parabola shape through the other dimension.
Oh, stop.
That is weird.
So we will work through. There's actually an entire packet that goes with this. It's really sweet.
It's like 3D.
No,
Wait, seriously does that?
also, this is math.
Numbers.
It's
They're
like
sweet.
math.
No, wait,
It's
like in
math.
real
That's
life,
not a
they
village.
hold it up.
Math is something completely different.
Is that the
That
case?
is weird. I can't.
No.
Oh yeah, that's what I thought. I thought that's what you were saying.
No.
That's too often. I know.
Second.
Square root of. Yeah. As well.
Alright, so radical 20 minus 4 is x, right? Well, you don't need to know radical 20, but the approximate answer is 0.47213595.
That's fine.
You can't. You have to do both. So, I have 0.47213595. 0.472135. 955.
Hold up.
So I believe for our first three here, we can express the first one with its perfect square root, right? 7 or negative 7. Second one, a little bit harder, square root of a negative. Third one. So we're going to end up saying for now that this doesn't work, right? But over here, we could factor this out a little bit if we wanted to. We don't have to necessarily quite yet. This one I think is a little bit easier. So actually, if we want to solve C, what's x end up equaling in C?
0.47213.
We don't approximate.
Well, it told you to have the approximate and the exact.
Okay, well, okay, so give me square root form first.
Alright. 20 minus 4 equals x. Square root of 20 minus 4.
Positive or negative square root of 20.
Yeah, Ava.
Wow! Thanks!
Or the square root of positive and negative 5 times 2 and then minus 4.
So, yeah, then the decimal, if we approximate, we have two, it's not positive or negative, right? We have two different answers. Yes? Right? Okay. So what do we get?
0.4721.
Okay, well, approximate.
0.4721.
Would it also be
Sure.
plus or minus? Well, positive or negative?
So, it might be easier if I go over here. So look at this one, and this will make sense. This is positive 7 and it's negative 7, right? It's either. When I deal with my 3, I add 3 to both sides. 2x now can equal, if this is positive 7 and I add 3, 10. But if it's negative 7 and I add 3, we have negative 4.
Okay.
So then, with either of those cases, x could be 5, or x could be negative 2.
We never finished the lesson.
Yeah, it's okay. It's literally okay.
But literally.
I wish we were in elementary school for math because we have like after blocks. When I went to teach, we played like 2 different games. We had the entire lesson
Right.
done, and we did a kickoff.
I wish we did too. So square root of 20
We all wish we did.
is 4.47. So if I subtract 4 from the positive, I get about 0.47. But if I make my answer negative and then subtract 4, I get negative 8.47.
I knew that. I just wrote it down as
So you cannot just approach it as the positive or the negative, because if this happens, it's going to shift both down. Yeah? Questions? DEF, do we need more time?
Yes.
Yeah? Okay. Take a couple more minutes, we'll go over these answers and get you out of here. Phoenix Fair is this weekend.
Yeah, I'm doing Phoenix Fair. I'm nowhere near being done, but you know.
I'm taking like an SAT practice.
Hey,
let's
go.
At work.
What?
The best
Where?
yeah,
The
wait,
SAT
wait.
and
Oh,
the
is it?
ACT.
Alright,
I don't know.
if we have it equal to 0, kind of easy, right? Because you can just make what's inside your parentheses 0, and this is fairly easy to solve. And I could actually turn it around, negative 10x plus 5. Anybody have an answer? We can skip some steps. Negative what? Well, yeah, but so negative 10x equals negative 5.
Oh, right.
So 1/2 is 0.5.
Half or 0.5, and it only has one answer? Okay.
Ow. That hurt.
E equals a negative value.
Not.
No answer.
So for now, I'm going to say no solution.
For now, it's scary.
For now.
Jenny? F?
Oh my gosh. Oh wait, actually.
I got negative 11. Oh yeah, I did solve it.
All right, subtract 5 from both sides.
Yeah.
I'll get x plus 11 squared equals 0,
So negative 11.
so negative 11.
Oh, hold on. I did something wrong then.
Question? No? Yes? Maybe? Let's see if there's anything else we need to touch on before we get out of here. You guys picked it.
One time where we were
Remember that one time?
Ethan, are you doing the SAT?
What? 14.
Are you also doing the
It's your day.
No, I'm not doing that.
Yeah, neither.
We might pick this up tomorrow, right here. Try your homework. Please let me know if there's questions. If there are questions, we will go back and practice tomorrow. So, hey, so hear me for a second. Your feedback on the homework, honest or not, will direct me tomorrow. So if you don't try your homework and you're like, oh yeah, it was fine, try the homework, give me feedback. Okay?
Does it mean that the homework's like iffy or something?
I tried it, but I didn't have to.
Is it hard?
No, but well, it depends. We are doing more of the same. So if we have any struggles, I want to do some more practice.
What I did wasn't very hard.
Okay.
So review and preview always. It will not all be crazy factoring quadratics. Review and preview. I will leave you with that visual.
What's the preview part?
Physically impossible to know. I mean, somebody could create like a video representation and you pull it up.
And you guys probably got to head out to SPM.